Ode by John Keats. Bards of passion and of mirth, ye have left your souls on earth. Have ye souls in heaven too, double-lived in regions new? Yes, and those of heaven commune with the spheres of sun and moon, with the noise of fountains wondrous and the parle of voices thunderous, with the whisper of heaven's trees and one another in soft ease, seated on Elysian lawns, browsed by none but Dian's fawns. Underneath large bluebells tented, where the daisies are rose-scented, and the rose herself has got perfume which on earth is not. And the nightingale doth sing, not a senseless tranced thing, but divine melodious truth, philosophic numbers smooth, tales and golden histories of heaven and its mysteries. Thus ye live on high, and then on the earth ye live again, and the souls ye left behind you teach us here the way to find you, where your other souls are joying, never slumbered, never cloying. Here your earth-born souls still speak to mortals of their little week, of their sorrows and delights, of their passions and their spites, of their glory and their shame, what doth strengthen and what maim. Thus ye teach us every day wisdom, though fled far away. Bards of passion and of mirth, ye have left your souls on earth. Ye have souls in heaven too, double-lived in regions new.
I can't think of a more appropriate introduction to a truly beautiful soul. Louis Pasteur. What do you know of this man? Of course, most people have heard of the Pasteur Institute and process of pasteurisation. Maybe you've heard that he discovered a treatment for rabies. But what do you really know about the man himself? Few individuals in history have dedicated their lives so entirely to the well-being and advancement of their fellow man. Born in France in 1822, Pasteur was trained as a chemist, but he was much, much more. He desired, above all, to ease the burden of disease and to discover the answers to the multitude of puzzling questions about the nature of life itself. He repeatedly challenged the scientific world in the fields of chemistry and biology and medicine and many other sciences by searching out the principles governing the unseen world of microbes. And like Cousin and Leibniz before him, he knew that the universe was lawful and knowable to the creative mind. He expressed that inner knowledge most profoundly when he said, "The greatness of human actions is measured by the inspiration that gives them birth. Joyous is he who carries within him an inner God, an ideal of beauty which he obeys, an ideal of art, an ideal of science, an ideal of his nation, an ideal of the virtues of the gospel. These are the living sources of great thoughts and great actions, and all of them are lit by the gleam of the infinite." Pasteur's actions were surely illuminated by the sublime. The greatest proof of that is something that is still as contentious today as it was then. His contribution to a dramatic increase in the potential of the population density of the planet. Perhaps one of the greatest leaps in potential ever realised. His discoveries in microbiology, which led to the practice of sterilisation, pasteurisation and vaccination alone, have made it possible for billions of people to live longer, more productive lives. His immortal ideas forced a change in the biosphere itself. The great Russian biogeochemist Vladimir Vernadsky, who Craig will speak of tomorrow, called this force of the creative mind the noosphere. But Pasteur had enemies, lots of them, enemies of humanity itself. None more so than the very unreverend Parson Thomas Malthus and his followers. Anne will talk more about him next. But contrast Pasteur's noble understanding of man's place in the universe, which you just heard, and his essential purpose for existence, to Malthus's degenerate view expressed in his infamous essay on population. Malthus said, "It is to the established administration of property and to the apparently narrow principle of self-love that we are indebted for all the noblest exertions of human genius, all the finer and more delicate emotions of the soul, for everything indeed that distinguishes the civilized from the savage state." And this so-called principle of self-love, which is supposed to distinguish civilized society, he said, requires that we should reprobate specific remedies for ravaging diseases and restrain those benevolent but much mistaken men who have thought that they're doing a service to mankind by protecting schemes for the total extirpation of particular disorders. So, what were those ravaging diseases which Malthus so dismissively referred to? Many of them are pictured here. Pasteur knew them only too well. In fact, he lost his eldest daughter to typhoid fever. He said, "When meditating over a disease, I never think of finding a remedy for it, but instead a means of preventing it." In the 18th century, over 60 million people died from smallpox. 80% of children under 5 died, and survivors went blind. In Pasteur's time, the mortality rate due to septicemia and infection in surgery patients was 50 in 100. However, following his breakthrough discovery of sterilisation to kill harmful bacteria, that mortality rate dropped to 5 in 100. Similarly, amongst women in childbirth, the death rate dropped from 200 in 1,000 to just 1 in 1,000. Enough to make Malthus and his anti-human sycophants choke. That Pasteurian passion and method must be revived once again. How could anyone doubt the great political and economic crisis facing mankind today, with massive cuts to national health budgets, with a veritable army of green environmental fascists on the march, calling for the culling of the human population and the shutdown of our food supply, and with the daily reports of new diseases breaking out, Hendra virus, whooping cough, E. coli, to name just a few. They can and must be brought under the willful control of man. Man acting truly as man. But how? As Mr. LaRouche has made abundantly clear on many occasions, it is only through scientific discoveries that mankind is able to increase his power to deal with the universe. And participating in a discovery, or even by learning a universal principle, you are creating the capability for the future of mankind. So, you need to use your imagination just as Pasteur did. Pasteur's grandson, Pasteur Valéry Radot, spoke on the occasion of the 100th anniversary of the discovery of fermentation, and he gave a beautiful, unique insight into his grandfather's imagination. He said, "A man of genius was needed to bring light in all this darkness. This man had the rare gift of insight." You will grant, ladies and gentlemen, that there are two ways for the human mind to gain knowledge: reason and imagination. In the modern world, dominated by technology, we are so accustomed to rational progress that we've come to hold imagination in too small esteem. And yet, without it, there could never be great inventors any more than there could be great writers and great artists. Imagination is in this scientific genius, assumes the special form of insight. This is the sudden intuition of a truth without the interposition of reasoning. Insight is what makes the scientists of genius foresee the end to be achieved. What contradictory qualities he must possess. Besides the gift of observation, he must be endowed with imagination, so he must be a poet. He must not be narrowly specialised. His knowledge must range over widely varied fields. He must discipline himself to assiduous labour. He must confine himself within the bounds of rigorous experiment, requiring him to bridle his imagination. End quote. This method of creative hypothesis formation which Pasteur exemplified was the same scientific method of Plato, Cusa, and Leibniz. They all had to deal with evil political and philosophical operations run by the old Venetian British Empire. In fact, Pasteur engaged in open polemical warfare against their number one operation, the doctrine known as positivism, a philosophy that denies all reality except those supposed facts of sense certainty. Unfortunately, positivism, unlike many of the other disorders that Pasteur was able to conquer, is a very insidious and stubborn disease. I want you to listen to what Mr. LaRouche said about it in his March 2010 EIR article called Mapping the Cosmos. And ask yourself this question: am I infected with this disease too?
It is an acquired mental disorder, a type of disorder expressed as the viciously systemic form of reductionism notoriously common to certain types of university professors and their students. The systemic pathology of the typical positivist of today is that he or she is usually essentially a nominalist of the type associated with Paoli Sarpi. Like Sarpi, today's positivist denies the existence of any knowable universal principles most vehemently. They permit no actual principles, but therefore rather mistake the mere name assigned to an object, a merely statistical behaviourist phenomenon, for the object itself.
Unfortunately, it's not just uni professors and their brainwashed student victims who suffer from this deadly virus. All of us here are infected to one degree or another as well, given that we live in a society dominated by positivism. The champion and founder of positivism in the early 1800s was the mathematical and statistical freak Auguste Comte, who I'll say more about shortly. But Comte did not operate in a vacuum. After all, there is no such thing, is there? There were several waves of Venetian agents who prepared the way for him. The first of these waves was directed by Antonio Conti, founder of the so-called French Enlightenment, who'd been given the task of launching a new Newtonian party in France following Leibniz's death in 1716. He activated the followers of Malebranche, who promoted Newton's straight-line corpuscular theory of light in preference to Huygens' wave theory. Conti's other chief agent was Voltaire, a truly sick, satanic satirist who attacked anything that represented beauty and truth. And he was famous for his philosophical letters, which were devoted to Isaac Newton, and for a thoroughly disgusting attack on Joan of Arc, but probably more importantly for the publication of Candide, in which he sarcastically ridiculed Leibniz's philosophy of optimism and the best of all possible worlds. Now, at this same time, there was a completely different political process underway in America, where before long the first true nation state republic would be born, in opposition to the oligarchical system of Europe. The Americans were challenging their British colonial oppressors for the right to trade and manufacture goods independently and to rule themselves. At the same time, Britain and France were in almost continuous warfare on the continent, culminating in the 7 Years' War of 1756. With the Treaty of Paris in 1763, the British colonial empire became the master of the world, and central to their control was the privately owned British East India Company, led by Lord Shelburne. Though headquartered in London, the BEIC was spawned by Venice and was a European-wide super conglomerate amongst whose chief weapons of imperial control were free trade, global free trade, and the ideological control of subject populations by controlling science and culture. In the face of this assertion of empire, a network of Republican agents throughout America and Europe began the fight for true political freedom. Under Benjamin Franklin's scientific influence, an industrial revolution was beginning. And by the time of the American Revolution, 1776 to 81, he and his associates were threatening to not only create new republics on the American model, but were also revolutionising real science in the service of the general welfare of the population. Now, in Europe, the French had joined America against England, and beginning in 1789 with the storming of the Bastille, the French Revolution was underway. But it was a pretty different revolution to that of America. To maintain their control, the British unleashed a lunatic Anglophile faction, the Jacobins, led by Danton and Marat, and the guillotine was put to work against all those who represent the greatest threat. The great scientist Antoine Lavoisier was amongst those put to death, with these words from the People's Judge: "The revolution has no need of science." By the end of the century, the British seemed to have France back under their control. They set their puppet Napoleon Bonaparte to work creating havoc and prosecuting his infamous Napoleonic Wars, which lasted up until 1815, after which they restored the Bourbon monarch, Louis XVIII. But despite this political control, there was a truly formidable factor in France which they did not have under their control. It was the École Polytechnique. The École was founded by Lazare Queneau and the genius Gaspard Monge in 1794. After the British and their continental allies launched war against France in 1793, Queneau stepped forward to organise the defence of France against invasions from all sides and defeated the attackers, which was a stunning accomplishment which won him the official title, the Organiser of Victory. The École Polytechnique very rapidly became the centre of renewal of the Platonic method of scientific discovery first established in France by the Brotherhood of the Common Life in the 15th century, and then pursued through the 17th century by Jean-Baptiste Colbert, who established the Royal Academy of Sciences with great scientists like Pierre Fermat, Leibniz's collaborators Christian Huygens, Jean Bernoulli, etc. Queneau was a devoted Republican and follower of Benjamin Franklin. In his essay on machines, he defined himself as a Leibnizian, maintaining that society can only progress through the scientific study of technological innovation. It was from that standpoint that he established a new basis for the study of mechanics, defined as the search for the best possible way for a machine to transform the energy flux. Now, that conception was exactly the opposite of the fixed Cartesian approach of the positivists. Queneau collaborated with Monge to form new generations of Republican scientists, both in France and Germany. Monge instituted a system of brigades based on Queneau's principle of enthusiasm, encouraging students to relive past discoveries. He held that when discoveries are made with the guidance of agape, that is the emotion that's associated with ideals such as the love of God, the love of justice, love of country, love of mankind, that it's possible under those circumstances to transform uneducated peasants and orphans into the best scientists and trained engineers in just a few years. Queneau made it clear that this principle of education was not just for France, but for the whole world. He wrote, "Elevate to the dignity of man every individual of the human species." Now, the second wave of positivists. Clearly, such benevolent intentions for the masses couldn't go unchallenged. So while Germany forged ahead developing these ideas, in France, the next wave of positive cult figures were unleashed. Monge and Carnot were stripped of all honours and removed from their posts in 1814 by the new Venetian-controlled Bourbon regime, which enlisted the services of 3 stupid, bigoted, narrow-minded and fanatical mathematicians. They were the Marquis Pierre Laplace, his lackey Baron Augustin Cauchy, and Adolphe Quetelet. Cauchy, at age 27, was a Jesuit-trained mathematician and an oligarch, and was designated to replace Gaspard Monge. He preached that man's mind is limited, that all ideas come mechanically from sense perception, and that knowledge is eternally fixed. Now listen to this evil insistence on the finitude of man's intellect. This is Cauchy. He said, "When one rapidly surveys the productions of the human mind, one is tempted to believe that human knowledge can grow and multiply to infinity. However, if one observes that all our intelligence and our means are enclosed within limits from which they may never break free, one will become convinced that our knowledge is limited. That if man has not been able to visit the poles, he is left in eternal despair of ever coming close to those icy regions. Who will ever dig a well 1,500 leagues deep? Man has risen 1,500 fathoms into the atmosphere, but the rarefied air will constantly bring back to the surface of the earth those who would want to undertake a bolder enterprise. The exact sciences are the sciences which can be regarded as brought to a close. Man can, by force of sophistry, be brought to doubt the truths taught to him, but he cannot discover new ones." Cauchy's superior and controller was the Marquis Pierre Laplace, better known as the Newton of France, for having championed Newton's work versus that of Kepler, Huygens and Leibniz, as seen in his publication Celestial Mechanics, which described the motions of the heavens in purely mechanistic statistical terms. Laplace stated that all the effects of nature are only mathematical results of a small number of immutable laws. So, you can blame Laplace for founding modern probability theory, but he also believed in something else that flowed from that, what he called causal determinism, which is expressed in this following quote. We may regard the present state of the universe as the effect of its past and the cause of its future. An intellect which at a certain moment would know all forces that set nature in motion and all positions of all items of which nature is composed, if this intellect were also vast enough to submit these data to analysis, it would embrace in a single formula the movements of the greatest bodies of the universe and those of the tiniest atom. For such an intellect, nothing would be uncertain in the future, just like the past would be present before its eyes. Mathematical analysis. Adolphe Quetelet was a student and disciple of Laplace, and argued that one could apply Laplace's statistical laws to human society to create a social physics which would be every bit as lawful and deterministic as Laplace's system supposedly was for the heavens. The key was ceaseless measurement and analysis of huge series of human statistics to arrive at what he called the moya, the average man. Quetelet studied rates of crime, births, deaths, marriages, and suicides to find the statistical trends and made extensive measurements of the human body. He became the president of the Belgian Central Commission of Statistics, was a main influence in the establishment of the London Statistical Society, and he organised the first International Congress of Statistics, held in Brussels in 1853. Quetelet's 1835 masterwork, called Man and the Development of His Faculties, was published by the raving eugenicist Robert Chalmers, who Anne will say more about. Chalmers crowed that Quetelet had made it clear that the stature, weight, strength, and other physical peculiarities of mankind are regulated by fixed principles of nature, as are his morals. And these doctrines rest on the most powerful of all evidence, that of numbers. Charles Darwin's cousin, Francis Galton, who served as his advisor on statistics, was in personal contact with Quetelet and based all of his founding work in eugenics upon his statistical methods. The intent of introducing systematized mathematical analysis as a universal method was to destroy human creativity. The word was, if you can't mathematize it, it's not valid. By the time Cauchy was eventually expelled from the École Polytechnique, the damage was so extensive that what was left of the school was but a ghostly shadow of its former greatness. But it was the positivists led by Auguste Comte who really consolidated this new evil doctrine. So the question is, how did he do this? Under the brand name of positivism, Comte launched a crusade to destroy metaphysics by name. the same metaphysics which Leibniz had established as being the actual substance of man's knowledge of the universe, as in his debate with the earlier positivists and reductionists, Newton and Clarke. In all physical sciences, we necessarily begin by collecting immediate and crucial data about natural phenomena via our senses: sight, hearing, touch, smell or taste, with the help of other artificial instruments like telescopes or microscopes, etc. For the positivist, though, this is where the truth about nature begins and ends. No conclusions can be drawn beyond direct personal experience. Max Planck, who Elisa will discuss tomorrow, gave a great example of this positivist problem. He said, imagine you're looking up at the heavens and you see innumerable points and patterns of light which move in a kind of regular way through the sky. The intensity and colour of those lights can be measured. For the positives, however, such impressions of sense certainty are the beginning and end of astronomy and astrophysics, i.e. their celestial mechanics. Planck polemicised against these positivists, saying this. He said, the mental constructions that we make in collating and selecting and systematising the measurement data and the theories that we advance to explain why they should be so and not otherwise, for the positivists, are an unwarranted human intrusion on the scene. They, the positivists, these measurements and data that we collect are merely arbitrary inventions of human reason. They may be convenient, just as the habit of thinking in similes is a convenient help to the mind, but we have no right to put them forward as representing anything that really happens in nature. Now, you all know what happens when you put a pencil in a glass of water on an angle. It appears bent, right? But of course, you know the pencil isn't bent. The positivist does not allow us to draw any conclusions from what we see, other than that it looks as if the pencil were bent. Similarly, no sentimental, aesthetical or moral considerations can be admitted. In the positivist view, a bunch of flowers is nothing more than a complex of sense impressions. We can note the colours, the perfume, the arrangement, etc. But if we take away all these sensory impressions, then nothing remains to correspond to what we name a bunch of flowers. You cannot draw conclusions as to why they are a certain colour and not another, or why they are arranged as they are and not otherwise. By contrast, in metaphysics, we hypothesize that our sensory perceptions do not of themselves create the physical world around us, but rather they point to another world which lies outside of our sensory experience, which is independent of us. This higher reality is where truth lies. Now, to advance his positivist doctrine, Comte founded a new pseudoscience, which he called sociology, in which he attempted to formalise social thinking based on the biological theory of evolution. Well, if organisms could develop over time according to discernible, deterministic laws, then it seems quite reasonable that societies could as well. Human society was compared to a biological organism, and social science equivalents of things like variation, natural selection, and inheritance were introduced as factors resulting in the progress of societies. So these social evolutionary theories had a monumental effect or impact on other key British Empire operatives, including Comte's close friend and co-conspirator, John Stuart Mill. Mill was the Rothschilds' prodigy put in charge of the British East India Company, who was close to the same age as Comte and who supported him financially for many years. Mill's disciple, Herbert Spencer, who coined the term survival of the fittest and propagandised for evolution well before anyone ever heard of Darwin, was also a devotee of Comte and a devout believer in the quack science known as phrenology, which held that the human mind does not exist because you can't measure it, but only the physical brain exists. Basically, Comte says that every social structure, every science and every individual goes through 3 successive stages corresponding to childhood, adolescence and adulthood. And each of these steps is a necessary and legitimate part of evolution. But only the final, only the positive state, what he called the positive state, is final. Let me explain. So these 3 states, the infantile or childlike state is what he called the theological stage, where man attempts to understand the universe by looking for causes for physical phenomena. But since the search is infinite and out of reach of human intelligence, he looks to God for answers. And Comte says this is a necessary stage in order for man to learn his limits. The second stage, the metaphysical or adolescent stage, is a transitional state in which abstract entities replace the gods and man looks for things beyond his reach, such as the origin and destination of things, the nature of the universe and the nature of beings. Comte said that the existence of such things can only be hypothetical. We can never prove them, and therefore they're of no interest to real science. And then thirdly, the positive adult stage. This is where man finally becomes reasonable because he understands that true knowledge of the universe is impossible and that universal ideas are hopeless. He no longer seeks for causes of the appearances of sense certainty, but only for mathematical formulas which merely describe them. The best example of positive law that Comte gives is Newton's law of gravitation. That, he said, man will never know the cause of the force by which bodies attract each other, only that this force is mathematically inversely proportional to the square of the distance between the bodies. And it is true because it can be measured and therefore will remain true for all eternity. Amen. In this final positive utopian state of Comte's, there will have to be a separation of powers, he said. Those who can most effectively run their own business affairs, especially industrialists and bankers, that type, must necessarily also run the world because they clearly have the skills. They've got the qualities of ambition, of self-interest that are essential to create wealth and prosperity for the whole of society. So now you know who to blame for the likes of Ross Garnaut and John Hewson and being given such high status over the last 30 years in this country. Also, Scientists. Scientists must become the new priests of a new religion of humanity, Comte said. And the Christian Trinity, Father, Son and Holy Spirit, well, that should be replaced by a feminine version, mother, wife and daughter. And on top of that, the evil of war will be inevitable and a necessary state of humanity. Because why? Order comes from chaos. Listen to Comte preaching in his own words.
It is still in doubt whether violent destruction is generally an evil as great as it is supposed. When the human soul loses its power through laziness, disbelief and infectious vices, following an excessive civilization, it cannot but be redeemed but by blood. Humanity can be thought of as a tree which an invisible hand constantly prunes and which is beneficial. Sure, the tree can die if the trunk is cut or if it's pruned too much, but who knows the limits of the tree of humanity? What we know is that excessive carnage is often associated with an excessive population. On the other hand, the true fruits of human nature, the arts, science, big business, noble designs, manly virtues, are exclusively due to the state of war. We know that nations never reach the highest point of achievement of which they are capable without long and bloody wars.
So in his relentless effort to reduce everything to discrete individual packets of knowledge, Comte also developed a systematic and hierarchical classification of all the sciences. They included on his list mathematics, astronomy, physics, chemistry, biology and sociology. Now the problem with this is that these classifications were totally static, while the sciences themselves, even in Comte's day, were rapidly changing, and so were all the boundaries of their fields. He also was not very big on scientific experimentation. After all, it runs the risk of creating paradoxes. And paradoxes can't be explained without hypothesizing. Now, he did, however,
Concede that some assumptions are necessary.
The use of this powerful device, hypothesis, must be constantly subject to a fundamental requirement, without which it would tend necessarily to hinder the development of our true knowledge. Truly philosophical hypothesis must always have the character of simple anticipations of what we might know at once, by experiment and reasoning, if a circumstance to the problem would have been more favourable.
So in short, the role of the hypothesis is simply to save some time on what is already obvious. Now, Louis Pasteur blasted this concept, which both Comte and his disciple, Emile Littré, who you'll hear about in a minute, held, this idea that they held of scientific experimentation. This is what Pasteur said.
The error of Auguste Comte and Littré is to confuse this method with the restricted method of observation. Both unacquainted with experimentation, they use the word experience in the sense in which it is used in ordinary conversation, where it has a completely different meaning than in scientific language. In the first case, an experience is no more than the simple observation of things and an induction that infers more or less legitimately from what has been to what might be. The true experimental method must go all the way to incontrovertible proof. In order to judge the value of positivism, my first thought was to look for inventiveness. I did not find it. Since positivism does not offer me a single new idea, it leaves me reticent and distrustful.
Now, the story is not complete without the next generation of positivists. Chief among Comte's disciples was Émile Littré, a French lexicographer and philosopher best known for his dictionary of the French language. Littré is often portrayed in cartoons of the day endowed with a monkey's tail, due to his notorious promotion of all things Darwinian. But he was also what they call a free thinker, a concept cooked up by the Venetians such as Antonio Conti and his stooge Voltaire. And it would appear he associated, Littré did, with the 1840s salon for London's philosophical radicals run by one John Chapman, publisher of the Westminster Review, founded by Lord Shelburne's agent Jeremy Bentham. Apart from dominating the evolution debate, Chapman's salon was a hotbed of free thinkers of every kind of kookery you can imagine. When Littré discovered the works of Auguste Comte, he was instantly converted. Not only did he become a close friend, but he devoted himself to popularising his ideas in works that are too numerous to list. When Littré died in 1881, he'd been a member of the prestigious French Academy of Sciences for 10 years. He was to be replaced by his nemesis, Louis Pasteur. It was customary for the new inductees to the Academy to present the eulogy for the person whom they were replacing. And this presented a profound challenge to the integrity of Pasteur, the scientist, but also to Pasteur, the compassionate human being. Pasteur spent months formulating his response to not only Littré, but also Comte and the whole doctrine of positivism. Here you will hear an excerpt from that speech.
Of Mr. Comte, I have only read a few absurd passages. My philosophy is of the heart and not of the mind, and I give myself up, for instance, to those feelings about eternity which come naturally at the bedside of a cherished child drawing its last breath. At those supreme moments, there is something in the depths of our souls which tells us that the world may be more than a mere combination of phenomena proper to a mechanical equilibrium brought out of the chaos of the elements simply through the gradual action of the forces of matter. What is beyond? The human mind, actuated by an invincible force, will never cease to ask itself, what is beyond? It is of no use to answer. Beyond is limitless space, limitless time, or limitless grandeur. No one understands those words. He who proclaims the existence of the infinite, and none can avoid it, accumulates in that affirmation more of the supernatural than is to be found in all the miracles of all the religions. For the notion of the infinite presents that double character that it forces itself upon us and yet is incomprehensible. When this notion seizes upon our understanding, we can but kneel. I see everywhere the inevitable expression of the infinite in the world. Through it, the supernatural is at the bottom of every heart. The idea of God is a form of the idea of the infinite. As long as the mystery of the infinite weighs on human thought, temples will be erected for the worship of the infinite. Whether God is called Brahma, Allah, Jehovah, or Jesus. And on the pavement of those temples, men will be seen kneeling, prostrated, annihilated in the thought of the infinite.
So at that time, when mindless positivism was inspiring so many so-called leaders. The very man who might have given himself up to what he called the enchantment of science, instead proclaimed the mystery of the universe. With his intellectual humility, Pasteur bowed before a power greater than human power. He continued his speech with the following words:
"Blessed is he who carries within himself a God, an ideal, and who obeys it. Ideal of art, ideal of science, ideal of the gospel virtues. Therein lie the springs of great thoughts and great actions. They all reflect light from the infinite."
So now you know something of the pitched philosophical and political battles that characterise the universe in which Pasteur lived and worked. Let me tell you about his most important discoveries. Pasteur's great-grandfather was a slave in France who bought his freedom in 1763. And his grandson, Jean-Joseph, Louis's father, was a tanner who fought with Napoleon in Spain. Joseph's only son, Louis, was born in December 1822, followed by 3 daughters. Joseph instilled in his son a love of science and played an enormous role in his education. Louis hated mathematics. His real love was science and especially chemistry. He was also a very talented artist, and in his youth he painted these portraits of his parents. But later on he also studied the Renaissance masters and he took frequent trips to the Louvre. Eventually, his studies gained him entrance to university at the École Normale in Paris in 1844, where he excelled in chemistry, physics, and teaching. He became the pupil of Jerome Ballard, who had discovered bromine in 1826, and it was Ballard who insisted that his students invent and create their own scientific apparatus, which Pasteur did throughout his entire life. Ballard instantly recognised Pasteur's intuitive genius, and he had him work as an assistant in chemistry. A short while later, Auguste Lorraine, a talented chemist, also arrived in Paris to pursue his experiments in crystallography, and he took a particular interest in Pasteur. It was about that time, 1846, that Louis Pasteur realised the importance of studying crystallography. He said of that time, he said, "When I began to pursue specific research, I sought to strengthen my abilities by studying crystals, anticipating that this would provide me with knowledge I could use in the study of chemistry." Little could Pasteur have known just how providential for mankind that decision would turn out to be. By the time he was 26 years old, he had conducted groundbreaking experiments on tartaric acid, which led to the breakthrough on what was to later become known as isomerism, and in particular, the dissymmetry of living organisms. The discovery of this universal principle set the stage for new higher order discoveries by Pierre Curie and Vernadsky. But first, Pasteur's discovery. There are a number of breakthroughs in the study of light, as well as the realm of physical constructive geometry as it applies to biology and living processes, which laid the foundation for Pasteur's work. This geometric tradition stretched back through the famous École Polytechnique to Leibniz, Christian Huygens, Kepler, Leonardo da Vinci, and, of course, Nicholas of Cusa. Most characteristic of this scientific tradition is the construction of actual geometrical models, some of which you see over there on the shelf. They're the platonic solids, wooden models. These models demonstrate the way in which processes work in nature. You should also note that this approach to understanding the shape of space and of living matter flourished at the Göttingen University in Germany through the work of Jacob Steiner and his rather famous student Bernhard Riemann, simultaneous with Pasteur's work. But Pasteur's discovery would not have been possible, however, if it weren't for the next generation of École scientists who applied Gaspard Monge's descriptive geometry language to the field of optics. These disciples included Étienne-Louis Malou, François Arago, Jean-Baptiste Biot, Augustin Fresnel, and their German colleagues Alexander von Humboldt and Eilhard Mitscherlich. Between them, they discovered the phenomena of polarized light, established the concept of optical activity, and invented the principal scientific instrument that Pasteur utilized for his optical experiments, the polarimeter. Their work established the modern scientific understanding of light beam optics and spectroscopy on a very firm geometrical, non-empiricist foundation. Now, it was known, thanks to Huygens and Leibniz, that a crystal of Iceland spar creates a double refraction as light passes through it. Watching the sunset through Iceland spar, Etienne Malou noticed that the two beams that normally appeared in the crystal were there, but as he rotated the crystal, one of them slowly disappeared and then reappeared as the other one subsequently disappeared. He hypothesized that the vibrating light beams coming through the crystal and the light from the reflection must have been separated into individual planes. Malou called this phenomenon polarization. Now, we don't use Iceland spar today to polarize light, but it's essentially the same. By blocking all the light waves except for in one direction, we can create a plane of polarized light. Now, regarding the polarimeter, this is a machine that measures the optical activity of a particular material or substance. That is, their ability to rotate the plane of polarized light. Now, to see how a polarimeter works, if you've got a pair of old polarizing sunglasses, you can do your own experiment with this. Take the lenses out, place one lens in front of the other, then look at a light source, preferably not the sun, but look at it through the stacked lenses. Now, rotate one lens, leave the other one stationary, and observe that the brightness of the light passing through goes from a maximum to a minimum over a range of 90 degrees rotation. When the second lens is aligned in the same direction, light passes through it easily, but if it's rotated 90 degrees, virtually no light can get through. That's the principle of the polarimeter. A polarizing lens at one end only transmits light that is vibrating in a vertical plane. The light passes through the test solution and may be rotated to the right or the left to varying degrees, which can then be measured directly by rotating the second lens until the light transmitted is at a maximum again. Now, for centuries it was known that a natural acid found in grapes, tartaric acid, formed salts called tartrates, which crystallized in wine vats. Now, you may have seen these crystals on the cork in a wine bottle. It was known that a solution of tartaric acid rotated polarized light, but it wasn't known why. In 1819, a second, very rare form of tartaric acid crystals was identified, which came to be known as paratartaric or racemic acid. Both the tartaric acid and the racemic acid had exactly the same chemical composition and properties, indicating that the arrangement of their atoms should be identical. However, in 1844, Eilhard Mitscherlich, the German chemist from Göttingen University, sent a report to the French Academy of Sciences describing how these crystals, though seemingly identical, had different effects on polarized light. When polarized light was passed through the solutions of racemic acid crystals, nothing happened. But when passed through tartaric acid, the light rotated. This paradox created tremendous debate in the chemical community. If every test known to science indicated that the two compounds were identical in every way, what could cause the difference? Well, as Pasteur said, to be astonished of anything is the first movement of the mind towards discovery. He took up the challenge to find the answer, and ultimately he discovered a fundamental principle of life. And I should just say at this point that LPAC TV and our basement team have done some really beautiful videos, including one on Pasteur's life, where they go through this experiment that Pasteur did in some detail. Pasteur began by drawing upon his own extensive study of crystals. His insight was to treat these chemical tartrate crystals in the same way as if they were mineral crystals, like quartz. Crystals which are symmetrical do not rotate polarized light. But quartz is known to be dissymmetrical and does rotate polarized light. Just like your right and left hands, some crystals can form identical mirror images of one another. This property of handedness is known as chirality. Pasteur was the first scientist to show that when examined closely, tartrate crystals, like quartz crystals, were hemihedral. That is, they had a small secondary facets on one side only, making them dissymmetrical as well. Like the quartz, they also rotated a plane of polarized light. Now, it was generally believed, in fact, that since all left-handed hemihedral crystals rotated light to the left, and all right-handed hemihedral crystals rotated light to the right, that the cause of the optical rotation was due to the particular crystalline structure, regardless of whether they were minerals or chemicals. However, there was a problem. This seemed to be true of quartz, but when it was crushed with a hammer or dissolved into a solution, the quartz lost its chirality, proving therefore that it is not a characteristic of the quartz itself which rotates light, but rather a characteristic of its crystalline space. Now, the same should have been true for the tartaric acid, but it wasn't. When it was dissolved in a solution, it maintained its chirality because the very structure of the molecules themselves was chiral. Pasteur proved that it was the asymmetry, or dissymmetry if you like, of the molecule itself which caused the rotation. But the question remained, why didn't racemic acid crystals rotate light if they were chemically identical to tartaric acid crystals? Pasteur initially thought that the optical inactivity of the racemic acid must be due to the symmetry in the crystalline structure. But, determined to prove his hypothesis, he took a solution of racemic acid and he allowed it to crystallise. Upon drying, he painstakingly examined each tiny crystal and discovered that these crystals also had dissymmetrical hemihedral facets. But this time he found both right and left-handed versions of the crystal. So he sorted them into piles of right and left-handed crystals, and then he made solutions from each pile. Much to his delight, they each rotated polarised light, one to the right and the other lot to the left. The reason the original racemic solution didn't rotate the light was because an equal number of left and right-handed molecules and crystals were formed, cancelling out any rotation. We now know that synthesis of any dissymmetrical molecule in the laboratory produces equal amounts of each isomer, that is, each right or left-handed molecule, and is therefore optically inactive. So, Pasteur now knew what the difference was between the tartaric acid and the racemic acid, but he still didn't know why. Now, he hypothesised that perhaps the answer might lie in the same phenomena that caused the process of fermentation itself, since the tartaric acid was a byproduct of fermentation. In one experiment he carried out, he fermented a solution of racemic acid. At the outset, of course, it was inactive towards polarised light. But as the fermentation continued, he began to see a subtle rotation to the left. This continued to increase as the fermentation proceeded until the solution reached a maximum left optical rotation, at which point the fermentation abruptly stopped. Pasteur evaporated this final solution and found that only left-handed crystals remained, where there had been an equal amount of both right and left before the fermentation began. So the racemic acid had seemingly turned into tartaric acid. Now, out of the two possible handed forms which composed the racemic acid as it started out, it was as if the yeast that caused the fermentation, which, by the way, Pasteur hypothesised might be a living process, it's as though that fermentation process, or that yeast, had literally consumed all the right-handed tartaric acid and had no appetite for the left-handed form. How was it that the yeast was distinguishing between the two forms of the acid? Did every yeast have its own little polarimeter to test the food before it gobbled it up. Pasteur understood that here was perhaps the clearest distinction between life and non-life. Under all non-living conditions, that is, without a process of fermentation acting on the racemic acid, the left-handed and right-handed tartaric acids behaved identically in all respects, except for the direction which they rotated light. However, to a living process, such as fermenting yeast, the two forms are as different as night and day. Therefore, natural tartaric acid, which is uniquely a product of living or organic processes, will always display a left-handed chirality, whereas racemic acid, which is not a product of organic processes, will not. One of Pasteur's old mentors, Jean-Baptiste Biot, asked Pasteur to repeat his experiment for him. Pasteur reported, he said, "The illustrious old man, visibly moved, took me by the arm and he said, 'My dear boy, I have loved science so much all my life that this stirs my heart.'" Pasteur's discovery was published to great acclaim in 1848, just before his 26th birthday. Now, Pasteur found that every active and naturally occurring biological molecule has a definite form which can be symmetrical. Or, I should say, which can be symmetrical, but most often are chiral, either right or left-handed. He showed that the taste of food is related to molecular asymmetry. One form can taste sour or sweet, while the identical mirror image molecule is tasteless. One right-handed molecule found in the rind of citrus fruits has a strong smell of oranges, but its mirror image, whilst chemically identical, has a piney turpentine-like odour. This dissymmetrical force, as Pasteur called it, operates only in living organisms and is the only well-marked line between the chemistry of dead and living matter. Now, whilst he could not have known it at the time, what we know today, the genius Louis Pasteur was already imagining in the right direction. 22 years after his original discovery, in a letter to Jules Roulin, a French chemist and biologist who was a close associate of his, Pasteur reflected.
You know that I believe that there is a cosmic dissymmetric influence which presides constantly and naturally over the molecular organization of principles immediately essential to life, and that, in consequence of this, the species of the three kingdoms, by their structure, by their form, by the disposition of their tissues, have a definite relation to the movements of the universe. For many of those species, if not for all, the sun is the primum movens of nutrition. But I believe in another influence which would affect the whole organization, geometry, for it would be the cause of the molecular dissymmetry proper to the chemical components of life. I want by experiment to grasp a few indications as to the nature of this great cosmic dissymmetrical influence. It may be electricity, magnetism.
In his last few experiments on dissymmetry, Pasteur placed crystals and plants in powerful magnetic fields to observe if there were any transformation in their optical activity or in their structure or synthesis characteristics. He even grew plants under conditions where the light was reverse polarized through the use of quartz and mirrors to observe the results in their geometric form. Unfortunately, however, Pasteur did not get back to this crucial work until close to the end of his life. He was needed to solve many other pressing biological problems instead. In 1854, at 31 years of age, Pasteur, with his wife and 2 children by this time, took up the position of chairman of the science department and dean of university at Lille, an important French industrial centre. Local workers and manufacturers would often sit in on Pasteur's weekly lecture on chemistry and its application to industry. A leading beetroot juice manufacturer came to Pasteur and asked for his help in finding the cause of acidic and fetid juice. Pasteur immediately came to his aid, taking his microscope with him. This turned out to be the first of many forays into biology. He soon discovered that round globules grew and multiplied in the vat of juice, and he recognised that this growing, dividing and growing again was a life process. And based on his previous work on tartaric acid and dissymmetry, he hypothesised that this could be at the root of the fermentation process. Now, people had been fermenting wine and beer for thousands of years, but the knowledge of how it worked wasn't known. Most people believed it was some kind of simple chemical action. Those who suggested that it might be due to a living force were absolutely ridiculed and seen as dangerous. So I guess Pasteur was dangerous. He asked the question,
where do they come from, these mysterious agents, so feeble in appearance, yet so powerful in reality, which, with minimal weight and insignificant external chemical characteristics, possess exceptional energy?
Pasteur carried out rigorous experiments which proved the crucial role of yeast, demonstrating that rather than a process of decomposition akin to death, fermentation was actually a life process, where yeast converted sugar into alcohol, carbon dioxide and water in order to release energy to fuel its own cellular activity and reproduction. He referred to fermentation as life without oxygen. Pasteur believed this was the mode of respiration and energy production in organisms prior to the emergence of photosynthesis and the release of free oxygen into the atmosphere of Earth. While yeast was responsible for the fermentation of sugar into alcohol in wine and beer, bacteria were responsible for converting alcohol to acetic acid in vinegar and lactose acid in yogurt. It was the contaminating microbes that caused ferments to sour. Pasteur's successes in treating the contamination and diseases of wine, milk, vinegar, and beer led him to the conclusion that microbes were also responsible for the many diseases afflicting animals and man. And this brought him directly into conflict with the proponents of the theory known as spontaneous generation. One of the most bitter and contentious issues in history, still to this day, an issue which lies at the heart of the Venetian-British assault on the true nature of man and the universe and of God, is this question of the origin of life itself. Does life arise magically from nothing? or from non-living matter, as the adherents of the spontaneous generation doctrine, otherwise known as abiogenesis, believe? Or does the answer lie elsewhere? For centuries it was believed that frogs, snails, leeches and many other things were born out of marshes and swamps. That mice would emerge from grain and dirty underwear left in a pot. So just put your undies in the dirty clothes basket. And turtles would emerge from sand. Aristotle, Plato's mortal enemy, asserted that life could arise spontaneously out of dirt or dust. Captured very nicely, I think, by Raphael in the School of Athens here. However, by the middle of the 19th century, most people came to believe that at least in the visible realm, animals and plants generate from seeds or eggs. But I can tell you it was a different question in the microscopic realm of bacteria and viruses. It was claimed that human disease comes from within, that viruses, etc., were generated spontaneously in the body rather than transmitted. So what was the answer? Where did these and other organisms generate from? And further to that, what was the origin of life itself? There were two prevailing and opposing views, as you might expect. The supporters of the spontaneous generation doctrine of abiogenesis were followers of Aristotle, Paolo Sarpi, and Newton. Many of them were closely associated with or part of the infamous X Club, formed in England in 1864 by the Rothschilds-controlled British East India Company under the watchful eye of John Stuart Mill, benefactor of Auguste Comte, the positivist, for the purpose of directing what became known as the Darwin Project. Again, Anne will give you more details on this next. The X Club's very reason for existence was to destroy real science and replace it with a new bastardized and publicly acceptable pseudoscience to crush any creative spark in the population. Those who opposed spontaneous generation were in the tradition of Cusa and Leibniz, and believed that dynamic universal principles define the universe. One of these principles being life itself, as opposed to arbitrary statistical interactions between particles of dead matter. Remember what Cusa had said about the universe being composed of the abiotic, the biotic, and the noetic? He said that we experience the being of true beings with respect to a threefold gradation. Some beings merely exist, others are alive, still others are alive and have intellect. Well, LaRouche expressed his understanding of life as a principle of creativity beautifully in his April 7th weekly report this year. The process of universal creativity, he said, gives birth to a physical universe of three distinct phase spaces, three distinct principles, each of which is creative.
You take what we have of life on Earth, the history of life on Earth, and what we have from that shows that there's a process of development which has no kinematic explanation. It's a process of creativity. Life itself is an effect of creativity. We have this sense of creativity as a principle on which the universe depends. You have kinematic processes, which are simply kinematic. You have living processes which are not cognitive, and you have cognitive processes. They all work in a similar way. They all interrelate. Obviously, life probably existed and mentally existed long before we knew anything about anything like that. There was never an actual beginning of intelligence per se, an actual beginning of life per se. There was a manifestation of life, a manifestation of intelligence, which we know as human intelligence. And the minute you think about this at all, you are forced to realize that there are principles which run the universe. And we're trying to discover those principles and how they work. But it's always principles. It never is deduction. If the universe functioned on deduction, it would have been dead before it was born.
In response to the loud polemics of those pushing spontaneous generation, Louis Pasteur proved scientifically through a crucial experiment this principle that life comes only from life and never from non-life. The leader of the spontaneous generation movement in France was Félix Pouchet, a single-minded fanatical materialist who, like the positivists, believed that the universe is reducible to interactions of matter in empty space. He was a friend and supporter of Charles Darwin and his ideas of natural selection and evolution. Pouchet ran a series of experiments in which he concluded that animals and plants could be generated in a medium absolutely free from atmospheric air. He knew that air contained some microscopic organisms, but insisted that they were very sparse. Otherwise, based on mathematical calculations, the air would have been darkened with the mass of their bodies. And to get pure air, you have to go to the mountaintops. So his experiments involved creating a broth by boiling infusions of hay in water to kill off any living organisms, and then adding only good, clean mountain air. He insisted that the germs or organisms that subsequently clouded the broth must have been generated spontaneously. Pasteur countered that Pouchet had either not boiled the hay infusion long enough to kill all the spores that were in it, or he had not prevented sources of contamination in the air. Now, Pasteur's teacher, Monsieur Ballard, had taught his students to make their own devices for experimentation. And Pasteur put this skill to good use with an ingenious invention that would be crucial in disproving spontaneous generation and affirming his germ theory. He invented a special flask called the swan-necked flask. In it, he put water, sugar, and yeast, and he heated the mixture until it boiled, and then he simmered it to kill any organisms that were present. When it was cooled down, a small wad of cotton was inserted in the neck, allowing air to enter the flask, but preventing any germs from entering. The solution inside the flask remained pure for months at a time. But when he broke the neck or tilted the flask, allowing some of the solution to run down the neck and back into the flask, it became infused with the previously trapped microorganisms and became cloudy. Pasteur repeated the experiment over and over and over again with the same results. He'd shown that a fermentable liquid, if exposed to pure, uncontaminated air, would lay dormant. Pouchet's less rigorous experiments always resulted in liquid teeming with germs, from which he then asserted that life could start in any place and that growth is found in every case regardless of the quality of the air used. Now, first in 1862, which was the year that Darwin's Origin of Species was translated into French, and then again 2 years later in 1864, the French Academy of Science set up a commission to test both Pasteur's and Pouchet's experiments. But each time it disbanded due to the enormous political controversy that this issue evoked. On April 7, 1864, Pasteur gave a lecture at the Sorbonne which was attended by many scientists, and he referred to his swan neck flask experiments, and he said, "Never will the doctrine of spontaneous generation recover from the mortal blow by this simple experiment." He went on to say,
As I show you this liquid, I too could tell you, I took my drop of water from the immensity of creation, and I took it filled with that fecund jelly, that is, to use the language of science. Then I waited, and I observed, and I asked questions of it, and I asked it to repeat the original act of creation for me. What a sight that would be! But it is silent. It has been silent for several years, ever since I began these experiments. Yes, and it is because I have kept away from it, and am keeping away from it to this moment, the only thing that it has not been given to man to produce. I have kept away from it the germs that are floating in the air. I have kept away from it life. For life is the germ, and the germ is life.
In England, Dr. Henry Bastian, a physiologist and founder of modern neurology, wrote a total of 7 books on the origin of life. He continued to publicly challenge Pasteur despite his conclusive experiment. Bastian was part of the Darwinian Young Guard, the first generation of scientists after Darwin's Origin of Species was published. He was convinced that the answer to the origin of life could be found in a laboratory, and he concluded that life could come from non-life, with no need of a supernatural creator, that is God. He was supported by a faction of the Darwinians, including Alfred Wallace, the supposed co-discoverer of evolution with Darwin. But he was opposed by ex-club members Thomas Huxley and John Tyndall, who feared that such a blatant refutation of the existence of a creator would bring the Darwinians into ill repute, as though they weren't already, especially with those liberal Christians who supported their evolutionary theory. Huxley insisted that Bastian should not publish his theories. When he went ahead and did so anyway, Huxley and Tyndall took Pasteur's side, at least for public consumption. Pasteur wrote to Bastian, Dr. Bastian, in July 1877, which is the same year the French Academy set up another commission to resolve the spontaneous generation question.
Do you know why I desire so much to fight and conquer you? It is because you are one of the principal adepts of a medical doctrine which I believe to be fatal to progress in the art of healing, the doctrine of the spontaneity of all diseases. That is an error which, I repeat it, is harmful to medical progress. From the prophylactic as well as from the therapeutic point of view, the fate of the physician and surgeon depends upon the adoption of the one or the other of these two doctrines.
Pasteur spent the rest of his life working on one biological challenge after another. He devoted 6 years to discovering the cause of an epidemic disease ravaging France's lucrative silkworm industry, saving not only the nation of France millions, but rescuing the farmers who were nearly wiped out by the disease. And this work on silkworms also helped him tackle other biological problems and led to his work on vaccination. Pasteur's insistence on the role of microbes in disease was picked up by the English physician Joseph Lister. Believe it or not, as late as 1892, most physicians still did not bother to wash their hands, let alone use clean bandages or antiseptic. There was an incredible 25% death rate among women in childbirth at the Paris hospital, where physicians would routinely deliver babies straight after carrying out autopsies. It wasn't until doctors were made to wash their hands with chlorinated lime water before examining pregnant women that the mortality rate dropped to around 2% at that hospital. Similarly, the effect of disease on troops in war was astounding. During the Crimean War, which was 1854 to 56, out of 300,000 French troops, nearly 1/3 died of disease and amputations done in the field. Only about 10,000 were killed on the battlefield. The mortality rate from amputations was 71%. Also in the US Civil War, the number of men killed by disease and amputations was 2 out of every 3 deaths. Pasteur never limited himself to one area of science. He wanted to understand the mechanism of the life cycle of different diseases, not as a formal interest of study, but with a passionate commitment to saving mankind from these diseases. And he said, "Nothing is more agreeable to a man who's made science his career than to increase the number of discoveries. But his cup of joy is full when the result of his observations is put to immediate practical use." Now, I can't go through in detail Pasteur's work on vaccination, but you can't speak of Pasteur without addressing this life-saving technology. Of course, we all know that there remains enormous controversy on this subject, most of which has to do with the very same Malthusian oligarchy which opposed Pasteur himself and which today seeks to destroy true science as well as the competent health systems that we once had. From as early as 140 BC, it was known that by drinking various potions containing poisons, a person could develop a tolerance. Snake handlers could become immune to the serpent's venom after numerous bites, and so could beekeepers. It was also known that a person could contract a mild case of a disease and survive, maintaining immunity to the same disease in the future. Thus, the idea of using a small dose of something harmful to develop a resistance to it was known for centuries. As you heard earlier, smallpox had been a deadly killer and unique to humans for at least 10,000 years. Direct injections of smallpox in a controlled manner had been reported in China and India for centuries, and inoculations were being performed in Constantinople by 1700. During the Boston smallpox epidemic 1721-22, the American patriot Cotton Mather introduced immunisation against smallpox into the New World, against tremendous opposition. These important contributions to the control of smallpox played an important part in the rapid acceptance of Edward Jenner's vaccination techniques 70 years later. Smallpox was finally declared eradicated worldwide in 1979 after a coordinated campaign of vaccination. Pasteur's work on immunisation and inoculation included treatments for chicken cholera, anthrax, and rabies. Perhaps the most destructive of these was anthrax, one of the oldest diseases of grazing animals known to man. The rod-shaped Bacillus anthracis reproduces rapidly within an infected animal and can kill within days or weeks. After the animal dies, the bacillus can form soil-borne spores which remain dormant in the soil for decades or often centuries, and if brought to the surface can reinfect other animals. Heating, harsh chemicals, burial do not kill these spores, and humans can become infected as well. Spores are found on every continent, including Antarctica. And it's pretty shocking that there's still many undeveloped countries that are afflicted with anthrax 130 years after Pasteur discovered a way to stop its spread. And this scourge could again become a nightmare if health and sanitation conditions continue to collapse. Pasteur's work on rabies was very personal for him. While growing up in the town of Arboy at age 12, he witnessed a rabid wolf bite up to 10 victims, 8 of whom died. While there were fewer than 500 reported cases in France in any given year, rabies caused such a horrible death that it had a profound and terrifying effect on anyone who witnessed it. He experimented for nearly 5 years before successfully treating animals, but he's best remembered for saving the life of 9-year-old Joseph Meister. News of Pasteur's success spread around the world, and patients came from everywhere, including the United States, for his treatment. But despite the international praise of his work, there still existed a nest of opposition. Pasteur Valéry Radot, his grandson, reported, "Certain doctors and certain journalists, always on the alert for something that might erupt into a scandal, pursued Pasteur with their attacks. Pasteur, it was charged, did not prevent rabies. He gave it." The public was invited to anti-Pasteurian meetings with the topics such as the alleged discoveries of Monsieur Pasteur, his heresies and frauds. Some things stay the same. Here is Pasteur's response.
I am the most hesitating of men, the most fearful of responsibility, so long as I am not in possession of a proof. But when solid scientific proofs confirm my convictions, no consideration can prevent me from defending what I hold to be true. If I had been more timid or more doubtful in view of the principles I had established, many points of science and of application might have remained obscure and subject to endless discussion. The hypothesis of spontaneous generation would still throw its veil over many questions. Your nurseries of silkworms would be under the sway of charlatanism, with no guide to the production of good seed. The vaccination of Chabon, anthrax, destined to preserve agriculture from immense losses, would be misunderstood and rejected as a dangerous practice. Where are now all the contradictions? They pass away, and truth remains.
Now you're going to hear more tomorrow of the legacy of Louis Pasteur, especially as his work on dissymmetry and living processes was taken up by Pierre Curie and Vladimir Vernadsky. But they were by no means the only ones who keyed off of his discoveries. In the 1920s, Russian-Ukrainian biophysicist Alexander Gurevich, who Robbie mentioned briefly this morning, like his contemporary Vernadsky, followed in the footsteps of Pasteur, Kepler, and Leibniz. Exactly for that reason, his work was systematically suppressed, especially in the West, where the Rockefeller Foundation considered it a threat to its promotion of reductionist molecular biology. Gurevich established that living cells and tissues generate an extremely weak, yet biologically active, form of electromagnetic radiation, in particular in the ultraviolet range, and that the presence of this radiation is somehow intimately connected with the nature of living processes themselves. He called this phenomenon mitogenetic radiation. Now, Gurvitch was led to his experimental demonstration of mitogenetic radiation as a byproduct of investigation of embryos and the process of mitosis, that is, the division of a cell into two genetically identical cells. Using onion root tip meristems, which are similar to stem cells in animals, Gurvitch tested whether a root tip brought towards another root meristem could induce increased rates of mitosis. The result was a 20 to 25% increase in mitotic cells in the other root stem. However, the effect could be eliminated if a glass plate that absorbed ultraviolet radiation were inserted between the roots. Now, this experiment raised many questions as to what was the source of the emission of this photon radiation, and how such a small amount of energy could trigger a process as complex as mitosis. Gurvitch took his investigations of mitogenetic radiation to the molecular level as well. He found that when weak electric and magnetic fields were applied to proteins and then removed, the proteins emitted ultraviolet photons. This was the beginning of his biological field theory, which raised the question of what it is that organises the unique properties of living systems. Now, in these opening decades of the 21st century, it is precisely this type of ongoing scientific investigation of the broad field of cosmic radiation and the space-time characteristics of biological and cognitive processes that Lyndon LaRouche and his basement team is leading. Their work is truly revolutionary and has already opened the door to the potential survival of the human species. Thanks in large measure to great scientists such as Louis Pasteur, upon whose shoulders they stand. Louis Pasteur was honoured by his friends and colleagues on December the 27th, 1892, the occasion of his 70th birthday. At this point in his life, he'd suffered several strokes, which left him unable to speak above a whisper. His grandson, aged just 5 at the time, later wrote, he said, "A grandiose ovation was staged at the Sorbonne. Representatives of the academies, the universities, and the scientific societies of France and from abroad paid tribute to him. The great Lister, speaking in the name of all physicians and surgeons, remarked that Pasteur had lifted the veil that for centuries had hidden the infectious diseases. When Pasteur got up to embrace Lister, there was a thundering applause in the huge amphitheatre. All delegates then presented to Pasteur the citations that they had come to deliver." Now, unable to personally thank the huge assembly, Pasteur's son delivered his response on his behalf. He said, "You delegates of foreign countries who've come a long way to show your sympathy for France have given me the greatest joy a man can feel who believes that science and peace will prevail over ignorance and war, that the nations will learn to understand each other, not for destruction but for advancement, and that the future belongs to those who have done most for suffering mankind." And then he called on the younger generation. He said, "Young men, live in the serene peace of the laboratories and libraries. Ask yourself first, what have I done for my education? And as you gradually advance, what have I done for my country? Until a moment comes when you experience the tremendous gratification of knowing that in some measure you have contributed to the progress and welfare of mankind. More or less favoured by the current of life as your efforts may be, you must have the right to say, on approaching the great goal, I have done all I could do. Thank you.